We now have Stanley Young from Neurosky, and Neurosky build biosensors, and he's going to talk about this, so I'm not going to waste any of his valuable time.
Well, while he's setting it up, I'll just start. We're a company that builds biosensors that basically provides the interface between wearable technology and humans. So in other words, a lot of the wearable technologies you see today, besides camera or motion sensor, they actually don't embed anything to sense your brains or your thinking or even your cardio signal or your biosignals. So back in 2009, when we first started, when there wasn't any wearable technology, we had to do something to bring this technology to the market. So we decided to figure out some way of making sure the technology is familiar for people. For example, back then, if I ask you if you can, am I ready? No? Okay. Well, it's a little stretch, but that's all right. So back then, if I ask you, people, if I can capture your brain signal and if you can control certain things, would you buy that for $100? And people would say, well, probably not. But we came up with this and everybody kind of bought it. It was a Star Wars. If I said I'll give you the Force, would you buy it? Yes. For $99, you can go to Toys R Us or at that time, I think Target. Even in Costco, they were selling that. That was back in 2009. Why? Because everybody loved the Force. If I said I was going to give you a brainwave sensor and detect your brainwave and give you the ability to control a ball, you really doubt it. But for some reason, if I told you I'm going to give you the Force, the consumers and the consumers just take it, right? And check this out.
Show me all. This is a really cool toy. What's this one? What is this called?
This is the Stinger.
Uh-huh. Okay. All right, so we've learned about that one. Come on out. Here. What do you know about this one? What is it?
It's the Star Wars Science Jedi Force Train.
Oh. Wow. That's amazing. All right. And you're rating these things, right?
Yes.
So how's your rating system work?
A 10!
Oh, my God. All right. What is the Stinger rate? We didn't rate that one.
It's a 9.
Okay. So there's a big difference between a 9 and a 10!
Well, that was very cute, and that also did a lot of free advertisement for us all over the place. Many shows kind of show that. Why? It wasn't because of the technology, it was because of the Force. But also it was because of the technology that attracted the Star Wars franchise to enable that particular game. So that's actually how we started the company back in 2009 when people really weren't aware of the wearable technology. And our vision was to create a biosensor that can read your biosignals, your basically anywhere from your body, wherever you wear that, and convert that to a digital signal so you can interface with whatever device you want to do. So back from 2009 to last year, something really cool. And there's a ton of applications in between since we started. And this was done by Audi, and we had no idea they did this with our European team until they showed it on the video. Of course, they have to change our Tesla logo to Audi logo. So. No, I actually met with their team, the whole team from Germany, their executive team last week. And we're talking about designing something interactive with the cars now. And actually, we have been talking to quite a few car companies in the past. When you're driving, you really don't want to do a whole lot of gesturing, waving your arm or doing something. You need to concentrate on driving. So a lot of that, a lot of your thinking and your biofunctions, biosignals can communicate with the car directly and tell the car, for example, turn on the music, it's too hot for me. All the sensors can sense all that and turn on the AC for you. How about a musical headset that actually senses whatever you're in the mood for and automatically select a song from your playlist for you? And this was launched last year at South by Southwest by one of our customers called Neuroware. And it received a pretty good big hit. And they're working now with a headset company to bring that to the market. From that to, and I'm just giving you a very limited sample of applications, to last year, a brain control arm shook hands with our president and won the White House Science Fair in 2013. And it was a 17-year-old guy named Chappelle, and he just used our SDK to build something and that could control the arm. Again, various different type of applications. I'm going to show you this for about 15 seconds. And I hope everybody here can figure out what this is. This is really junior high level. Okay, and after a few seconds, going to ask you, can you explain what just happened? Now, if you took your chemistry class, you should know. But what you just saw was a cloud-based interactive textbook. Although in the US we're a little slow because the schools are very fragmented, we are working with foreign Ministry of Education on bringing this type of multimedia learning to schools. Why multimedia? It's always easier to kind of watch a movie or watch a video and learn certain things. For example, what you just saw, it was very easy to understand. The ice would float on water, but it would sink in the alcohol. But if you were to describe that in text form, it's pretty boring, pretty hard for the kids to understand. And myself, for example, I graduated from UC Berkeley back in the late 80s and with an engineering degree, so I didn't really have to take the English class for grades. I promised my professor that if she gave me a passing grade, I would finish War and Peace before I die. I'm halfway through now after over 20 years of reading it, still next to my bed. But I'd like to inform everybody I've watched the movie twice, so I know what the ending is. Why is that so easy for me to watch a movie in 2 hours and so hard for me to read a book in 20 years? Because the book was immensely boring, and at least I could stand the movie, and it was only 2 hours. So multimedia learning is extremely important, and that's what this biosensing is all about. We need to make sure we interact with our world. It's a multimedia experience. We interact with our world in a very 3D, with our five senses kind of form. We use our five senses to learn, to protect ourselves, to learn knowledge, to interact with each other, and to see things and to smell things. But there are signals that we actually don't know and we don't have. We don't have that sixth sense. So I dare to call the sixth sense is digital in the future. We're going to use biosignals to tell you what you don't know. For example, how many of you actually know your heart is okay or not okay? It's one of the biggest killers in the human history is a heart attack. But nobody knows if you're going to get a heart attack until you actually get to that point. Why? You don't feel anything for it. How about your liver? It has no nerve inside, or your brain, you actually don't feel anything in your brain. There's no nerve. When you feel headaches on the edges, usually it's not right in the brain. Those organs will not give you any pain signal, therefore you don't feel that. It's not in your five senses. Our digital sensor or our biosensor can provide a digital signal to your devices and have you interface with that. And hence, it's not only designed for brain wave sensing, we're getting designed into cell phones as well. And this is an example in China where they have a lot looser FDA requirements. They can do a lot more. And this is an advertisement for a smartphone that integrates our biosensor and actually detects your cardio health and give you all kinds of recommendations for that day, down to what you should eat, how much you slept, have you slept well, and all that. And it's quite useful. Even the quality of air you're breathing at the moment that you're testing yourself. So the sensors are penetrating into quite a few different designs, not just for fun and games and education, but also for health and fitness tracking. I am wearing perhaps the most expensive of them all, $1,800 each. And for example, in 2 seconds, I can display my ECG on stage. I can't physically or legally sell this because it's not FDA approved in the US, but in many other countries, we have started deploying this technology. And we're working with FDA in the United States to hopefully bring this technology to the United States. It would be a shame that it's all invented here in the Valley, but we can't use it in this country. So with that, I don't know how many minutes I have left, 3 minutes. Should I take question or should I give a little story?
Well, do we have some questions, or would you like to just let? Oh, okay. Which would you prefer? Question? Yes.
I'll take questions.
Lovely. Thank you.
Yeah, what is the long game for your company for this? Are you looking for integration into wearables, considering that if the sensors are based right on your head, and even longer term, are you looking at things like fMRI to measure blood flow and that sort of thing, and then integrate that into a way that you're actually constructing thoughts in augmented space based off of the sensors?
Our vision has always been trying to get integrated into wearable technology. So we are working with quite a few of these wearable companies, whether you wear them on their wrist, on their face, on their head, musical or glasses, or somewhere on your body. We work with them whenever they require to measure or to sense your biosignals and somehow convert that into useful information. In fact, right before the speech, I even talked to Alex earlier. He was showing the Mayo. Inside, there are biosensors that we can help to make it a lot more sensitive and a lot less false positive.
It just seems like an easy integration with something like
this.
That's
So, by the way, the sensor is 3 millimeter by 3 millimeter. It's very small, so it can be easily integrated into just about anything. That's how we got into the smartphones, into wearables, when the wristbands, when they're so small, and they are quite low power.
Do you have a non-contact solution, though, the way Thalmic does?
Yes. So we do have both contact sensor and non-contact sensors. Obviously, the non-contact is a little more expensive, but we're talking toy grade kind of price. So yeah. And in fact, we have a new technology. I can't really discuss that here. First, we don't have time. Second, we will disclose that in January next year. And it's quite revolutionary. It's non-contact, and it can measure quite a few things that even our technology today cannot measure.
I think because we're getting so close to lunch, if there aren't any urgent questions, we're just going to move on to Mark Billinghurst's demo that he's now got working. So this is really neat. I just was watching over his laptop. Thank you, Stanley.
Sorry for the problem last night, or just before, but I just want to show us a really quick video. It's just 40 seconds, and it shows, again, how you can use speech and two-hand gesture to interact with AR scenes. What you'll see is you'll see this guy using a modeling interface to model a simple scene, and then what he does is he grabs the real world and scales the world and goes immediately into an immersive VR setting as well. So you can both go from AR to VR as well. And you can try this for yourself on the show floor over lunch, if you like.
Spin solid.
So he's using single word commands. He's now creating an extrusion plane. He can draw on it, and it creates an object. Then he can reach in and scale and move the object around.
Extrude as solid.
And so now he said extrude solid. Now he's drawing again an extrusion. So it's a modeling, and it pops it out, and there's a little scene object there. You can pick around. There's physics in there, so the objects bounce around a little bit. It's a 3D user interface, so you can see all the icons on the side. So you put your finger in the icon to select, and you can color. You can change object size. You can move them around and so forth. So this object now is selected. Now he's going to map the rotation of that to his right hand. So as he moves his hand around, it rotates the object. And going a bit faster. And then you'll see him change some colors, touching, and then he just scaled space right there. So if you grab the fabric of space and stretch your arms out, it moves from an AR scene into an immersive VR scene as well. And then you can do the reverse. You can grab the VR scene and scale down. And here's all the technologies we combined to make that happen. So it's quite a lot of stuff. But please go and try it at the show floor. It's not working quite as well there as it is on the video because of the tracking with the lighting conditions, but you get an idea of how it works out. So thank you very much for the time, Tish.